Now that you know electron configuration using orbital diagrams and shorthand notation, you can figure out valence electrons and ions using that. So first of all, let's examine the element sodium. Sodium is element number 11 on the periodic table. That means that as long as it's an atom and not an ion, it's going to have 11 protons and 11 electrons. If we were to draw a Bohr model diagram for that, then this would be the nucleus, and then this would be the first energy level, second energy level, third energy level, and the electrons would be represented as dots on that. First energy level can hold 2 electrons, so I'm going to put one here and one here. That energy level is now full. The second energy level could hold 8, so I'll put 2, 4, 6, 8. That takes me up to 10. I need 11, so that last one would go on that outermost energy level. These are the valence electrons on the outermost energy level. It's easy to tell when you draw it in a circle because you just look at the last circle. But when we do orbital diagrams, you would use the SPDF periodic table. First 2 electrons are in 1s, so I would draw one orbital, call it 1s. There's electron 1 and electron 2. The third and fourth are on the second energy level in the s sublevel. So here's my one orbital for 2s, that's electron 3 and electron 4. Electrons 5 through 10 are out here on the second energy level, p block. So 2p, I draw the 3 orbitals, and here's electron 5, 6, 7, then back 8, 9, 10, and then electron 11 is on the third energy level. It's yellow, so it's in an s sublevel. So I draw the 1 orbital, and there's my 1 electron there. We don't see the rings to see which one is the outermost, but remember that these big numbers in the front talk about the energy level. So this is the first energy level, the first ring. These two are both sublevels of the second energy level, which is this ring right here. This is a sublevel of the third energy level, and it's the biggest number, it's the outermost energy level. So we would circle or highlight that these are the valence electrons. We love valence electrons because they are what determine whether an element will react or not. We could also look at another element that would have slightly more complicated valence electrons, like fluorine. Fluorine is number 9, so it has 9 electrons as long as it's an atom. The first 2 would be in 1s, the second 2 would be in 2s, and it only has 9, so the remaining 5 would be here in 2p, like this. So the valence electrons are the ones on the outermost energy level. This is the first energy level. Both of these are part of the second energy level. So these are the valence electrons all together. Anything on the second energy level is going to be a valence electron for this atom. Then we can look at it in shorthand notation, and that lets us look at slightly larger elements. So we're going to take a look at zinc. Zinc is number 30. And if we're doing shorthand notation, zinc starts 1s, has 2 electrons, 2s has 2, 2p has, 6, 3s has 2, 3p has 6, 4s has 2, and in 3D, because it's number 30, we're going to go all the way through 3D to the last one, and it's going to be 3D10. Now picture the rings. Come back up here and picture the rings. First ring is the first energy level. Second ring is the second energy level. Third ring is the third energy level. We actually have electrons out on the fourth ring, the fourth energy level. That makes just those 2 right there our valence electrons for zinc. 2 valence electrons, because of that energy level number being the highest. If we did another slightly complicated one, tin. Tin has 50 electrons. So it's got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p. It's only going to go to 2. It's the second one over in 5p. So it's 5p2. Think about the rings, first ring, second ring. All of that is the third ring. All of that is the fourth ring, fifth ring. 5 is as high as it gets, so these and these are the valence electrons. Tin would have 4 valence electrons.